Yo, 2016 Physics Unit 1 paper. Question 2, our particles, subatomic particles question. It's a cracker this year, it's lovely. State the difference between baryons and mesons in terms of quark makeup. So we have 2 marks, right? So we've got to give them 2 things to work with. Baryons consist of 3 quarks. You don't have to give examples, but you could, you know. Proton, neutron, delta plus plus, etc. Mesons consist of 2 quarks. But I think to get that second mark, you have to specifically say those 2 quarks are a pair of quark and anti-quark, right? So quark, anti-quark pair for a meson. 2 marks there. There's a collision. 2 protons give a proton, an unidentified as yet particle, and a pi zero meson, which means that has no charge. The pi zero is a meson which carries no charge. State its quark makeup, right? So it's got to be a quark anti-quark pair. And the only way you're going to end up with no charge is with a U and an anti-U, or a D and an anti-D. You didn't need to put both, I just did to explain it. Obviously, if it was a combination of U and D, you would have ended up with a pi minus or a pi plus. Right, so they ask us to identify the undetermined particle X using conservation of baryon and one other conservation law. Right, so I did this in a funny order, so bear with me. Right, baryon, there's 2 on the left. Protons are baryons. So there's 1 there, that's 2. On the right, there's 1 there. That's not a baryon, that's a meson. So this must have a baryon number of 1. This must be a baryon. It must be made up of 3 quarks. Right, so we think in proton, neutron, delta plus plus, for example. If we look at charge, proton's got a charge of 1. 1 plus 1 is 2. There's 1 on the right. That has no charge. So this must also have a charge of 1 for the charge law to balance. So it's got to be a baryon with a charge of 1. The particle is a proton. And then state how lepton number is conserved in the above interaction. I did it up there accidentally. Not a lepton, not a lepton, not a lepton, not a lepton, not a lepton. Zeros all around. That's how it's conserved. Right, no problems there. They haven't asked us about what force is going on, so that's probably the next question. They tell us that the meson decays in 8 times 10 to the minus 17 seconds into 2 photons. There they are, there's my 2 gammas. State which force is involved, giving 2 reasons for your answer. Right? So there was 3 or 4 reasons you could have given. You've only asked for 2. So 1 mark for saying it's the electromagnetic force, and then another mark for saying photon emission is 1 reason for electromagnetic. The lifetime is too long for it to be the strong force. It's too short for it to be the weak force. You could have also said if it was the strong force, it'd only be quarks involved, and of course these are not, these are photons. And you could have also said it can't be the weak force because there's no involvement of neutrinos. So a nice easy 3 marks there and a very nice particles question. Goodbye.